Hi everyone, and welcome to another SWAT Explains session with Zane and Fred. Today we're going to be looking at the Watson AIOps Event Manager, specifically around the topic of noise reduction. So this is a part one of this particular topic, and we're going to cover some elementary aspects of noise reduction in the Event Manager. We're going to talk about today what is an object server, what is object server noise reduction, and why do we need it? We're going to look at the basic object server triggers and automations that perform the default out-of-the-box noise reduction, and then we'll intersperse that with demonstrations by Fred using a demonstration probe. Just to give you an idea of the parts that we're talking about today in the Watson AIOps solution, we have the main parts of Watson AIOps is the Event Manager, the Metric Manager, and the Topology Manager. And today we're going to be looking at the events coming into the Event Manager and how they are surfaced and visualized on the dashboard. And we're going to look around all of the techniques that we use traditionally to reduce noise in the Event Manager, making the events a lot more manageable. So core concepts for noise reduction. In the Event Manager, we receive hundreds of millions of events per day, raw events. These events come into the Event Manager. Many of these events can be discarded in the probe rules if they are of no value, either informationally or from an alert perspective. Then they come to the object server. So what is the object server? So within Event Manager has its core component coming from the Netcool solutions. And the object server is simply the event store, which is embedded within the Event Manager. So when we use the term object server, we're simply referring to the event store, or the component that receives and stores the events. It's also where a number of automations happen, including the noise reduction ones. And these are the ones that we will be talking about principally today. From there, events can be further reduced by flowing into other event processing engines, such as Netcool Impact. And then when they get to the UI, you can apply filters, which will further reduce what events you see on your screen. And then we have a whole bunch of event grouping that goes on within the Event Manager. So we have scope-based grouping, event analytics-based grouping, and topology-based grouping. These topics are covered in another SWAT Explained sessions, so look out for that one separately. And then finally, once events are grouped by one of these three grouping automations, they can be further grouped into what we call supergroups when the events actually span across multiple groups. So today we are focusing on these three parts of the noise reduction process. So raw events coming in, how they may be processed by the probe, and then how these events are further consolidated using these noise reduction automations in the object server. Okay, so first of all, what is an object server? So as I said before, the object server is the data store component part of the Event Manager. And it's basically the same event store that has come from the Netcool Operations Insight or Netcool Omnibus solution. So it is the central event store for the Watson AIOps Event Manager overall, regularly checkpoints to disk. However, it is memory resident. One of the main features of the object server is that it is extremely fast and extremely efficient, because
very flexible as well, isn't it? So
yeah,
you can add stuff on the fly.
Yes, because it runs in memory, it's extremely fast, unlike traditional disk-based storage systems. So as well as the automations that we're talking about today, you can create your own custom automations, and it can also synchronize with a user repository, although this is superseded if you sort of integrate into LDAP directly. So you can extend this event store with your own custom databases and tables. You can think of it a bit like an SQL database. It's certainly you interrogate it and manipulate it and interact with it as if it was an SQL database. The front end to it is Sybase. That's why Sybase-based libraries are used to interact with it. However, underneath the covers, it is a proprietary data store. So other interfaces that the object server has is the IDUC capability, inserts, deletes, updates. And this is where gateways and other IDUC clients interact with it and receive those updates.
There's a Perl script interface. So in the past, we have done scriptings based out of Perl scripting language. And there is a possibility to directly use out of a Perl script the object server. So this is how it is done. So it's with the piggybacked into a Sybase interface.
Yeah. It's also a REST API, and you can connect to it in many different ways. So this is a quick screenshot of the Netcool configuration tool, the Netcool administrator. And it's just showing you on the databases that are embedded within an object server. You have a number of different databases and tables. The one that's actually being shown at the moment is called the alerts.status table. And this is the table where events are injected and are stored. As you can see from the screenshot, there's a whole load of different default fields where event data can be stored. And the identifier field, which is highlighted, is the primary key for the event table. When we look at the demo shortly, we'll be looking at a probe and a probe rules file, and we'll take a look at how an identifier looks and how it needs to be unique in order to be able to differentiate each alarm from the other. So moving on, which are the important triggers for noise reduction? So today we're going to take a look at the deduplication mechanism, the delete clears mechanism, the generic clear mechanism, and the expire mechanism. So all of these are implemented as object server triggers. Some of them are database triggers, which means that they are executed when a database action occurs, and some of them are temporal, which means they're time-based. So we'll take a look at each one in turn, and Fred's going to give us a demo of each one.
Yes, sir.
So out of the box, we have 119 different automations and triggers in the object server. Most of them are active. Some of them are out of the box disabled and can be switched on if they are needed. As it says here, they can be modified, extended as the databases and tables, and you can add your own triggers. One caveat to this is we would always say, don't modify IBM triggers. If you have some custom automation that you want to implement, it's best to create your own trigger and do your automation there. If you really need to customize the way an IBM trigger works, the best practice is simply to make a copy of it, disable the IBM copy of it, and make your changes in your custom one. The main reason for this is if we ever roll out sort of updates to the IBM triggers, when fix packs and so on, those modifications may be overwritten. So best practice is do your customizations in your own triggers, ideally.
Very good insight. And I think we're going to highlight the best practices that you and a couple of other people have collected in our documentation section in one of the slides at the last of this presentation.
That's right, yeah. So now we'll take a look at the automations. So the automations, as mentioned before, they're basically analogous to a database trigger. We have three different types of triggers in the object server. We have a database trigger, which is triggered on a database action, such as an insert, delete, update, or reinsert. And we'll talk more about reinsert shortly. We also have a signal trigger. So when there's some sort of signal raised in the object server, such as a gateway connecting or the object server starting or the object server shutting down, various signals internally are raised in the object server. This can trigger triggers if there are triggers watching for those signals. And the third one, which is probably used the most, is the temporal trigger. And that's basically just a trigger that will run every predefined number of seconds or minutes or hours. So these are what you can see on the screen now is a list of the ones that come out of the box. The highlighted one is one of the ones we're talking about today, the generic clear. So let's take a look at them. Right, so the first automation we're going to look at today is the deduplication automation. So if you think about a database, a traditional database, you tend to have an insert, an update, and a delete action. Those are the main database actions that an SQL database will have. And the object server is no different. It has those three. It also has uniquely the concept of deduplication, which is essentially a reinsert. And the definition of a reinsert is when you are inserting the same record into a database table with the same primary key field. So in event terms, this is basically receiving the same event twice. So we might receive, for example, a link down alarm from a switch, and then a few minutes later, the switch still has its link down, so it sends the alarm again, just to tell you about it again. Now, in a normal database, if you tried to insert the same record with the same primary key, you would simply get a failure, an error, and the secondary insert would not happen. But in an object server, we actually have the ability to catch the attempted reinsert and perform an action. So the default behavior for a deduplication is to actually do nothing. If you create a trigger to catch it, though, you can actually tell it to do some things. And the default deduplication trigger in the object server does a few things, such as increment the tally, such as update the severity, such as update the summary field, and so on. So we'll take a look at the actual nuts and bolts of the deduplication trigger, and Fred is going to give us a demonstration of it. So in the screenshot here, you can see the deduplication trigger in the Netcool administration tool. You can see this is a database trigger, and it is firing prior to the attempted reinsert. And as you can see, the radio button has reinsert. So this is unique to an object server database. This is the default code for the deduplication trigger. You can see if the incoming application name is probe, in other words, the event is coming from a probe, it first of all looks at the last occurrence and the subsecond IDs to make sure that the events are coming in the order that they were generated. It then goes through and updates a number of fields based on the incoming event. For example, it increments the tally field, it updates the last occurrence, the state change, the internal last, it updates the summary field with the new incoming summary, the alert key, and another timestamp here.
And the getDate function is a function which inserts the current date.
That's right, Fred. Yeah, indeed. And then that last little if statement is saying if the current severity is clear and the new severity incoming is greater than 0, then I want you to update the old severity with the new severity. Right, so now I'll hand over to Fred to give us a demonstration.
Thank you, Zane. So now let's have a little look into the details of deduplication. And for that, we do have a demonstration capability, and the demonstration capability is called Simnet Probe. But before we go into the depths of setting up a probe and configuring and twisting it, I would like to introduce the overall architecture that we're going to use today. We are seeing today an installation. So we're using an installation which is based on the IBM Cloud, which is a Red Hat OpenShift cluster. We have detailed that in another video. So installation of Watson AIOps Event Manager in less than 1 hour. That's the video which details that, how to set this up. And that is connected to the internet, which is here in the middle. And I have locally installed a laptop which is running Linux, Fedora, and on that I do have a local installation of Event Manager. And from the local installation of Event Manager, I'm going to use the Simnet Probe. This is a simple setup, so no failover in here, just one single probe, no master and slave, even if it says master. And I'm also going to use the configuration user interface NCO config from that install. So both of the tools are coming out of the box of each and every installation that you do with Event Manager based on Linux. So that's the setup. Just to explain, what is a probe doing? A probe is connecting to specifically just one source. That's what I call event stream here at the top of this slide. The probe knows how to connect there because it's a dedicated probe. Usually we have vendor-specific probes or source-specific probes. Source-specific can be, for example, it can be an SNMP trap. It exposes a trap receiver port, or if you're using the syslog probe, you would set up a stream on the syslog stream. So it can be everything of the syslog stream, or it can be a specific part of the stream based on a filter that is exposed to the syslog probe, and so on and so on. We have gazillions of these probes which are capable of connecting to almost anything that is available over the network. The probe knows what is the beginning of an event, and it exactly knows what is the ending of an event. As soon as both of these markers have been detected, then it knows everything in between must be a single new event. That is copied, and that's exactly the point in time when the content of that technical detail of that new event is secured. So as soon as the probe it receives it, there are mechanisms to really secure it in terms of connection loss or failover or whatever kind of disaster may happen to you. There are ways to secure this event, and also when connectivity is restored, to make sure that this particular event is then delivered to the object server. All that is there, that is present. These are base principles of Watson AIOps Event Manager. And the first step, after we have copied this single event, then there is a tokenizing taking place, and we do create tokens, which are denoted here with the dollar symbol. And that is the source that is made available to the next step. And the next step is a rules file. So rules file is a text file that we're going to look at a little later on. So the purpose of this rules file is to map the raw data that is coming into the rules files as tokens, which reflect the raw event data, and to map that to the format that is in the object server. So the object server itself has a database, alerts.status, that comes with fields, as you can see in here, node, summary, first and last occurrence, and so on and so on. And that format is the target format, and the rules file contains simple rules, which make sure that the raw data is mapped to the object server format. And the last step of this is then a handshake. So the probe makes absolutely sure that the object server has positively acknowledged the receipt of this new single event. And it's then up to the object server to use that event and to insert that into the alerts.status table. So now let's open the configuration interface to the object server and have a look at the object server. What I do is I'm going to raise the user interface to that. And that's called NCO config. Push that in the background. And we do have a new process coming up. This little fellow here is the process control, which is configured, but I don't care at the moment. What I do care about is the object server components, which are registered here. ACB is the backup object server, which is configured here on my laptop called Batman. P is the primary object server. V is then the virtual shell that puts everything together. So if I connect a probe to the V object server, then that's the sign to do the failover. So everything that is connected to the V object server knows how to fail over between P and B. That's how it's done. Then there is my IBM Cloud installation, which is here. So thread OCP P for primary and B for backup, and again the virtual shell in here. And as you can see, this is connecting to my ROX environment. How to set this up, we have detailed in a different video. This is going hybrid. So Zane and I speak how to do this, how to set up the TLS handshake, doing the secrets and all these kind of pieces. And now we have this configuration user interface connecting to my object server. And the object server itself needs a username and a password. So out of the box, there's just one single user in here, which is the root user. And I'm going to use the password. So we know from the secret in the ROX environment what the password of the root user is. If you're not sure where that is, you can dig it out. Need to connect to my cloud environment using my ID. In here we have the OpenShift environment and clusters, which are configured. In here, thread pool is my space, where I have installed my event manager environment too. And in here, we open the web console. And within the web console, we do have the secrets configured. And the secrets are here on the left side. And within the secrets, we look for the noise secrets. And in here, I do have my Omni secret. And this is the out-of-the-box omnibus root password. And with this little button, I can copy it. Let's get back to the configuration interface. nco config background is here. So object server on rocks, primary object server, this one going to connect to username root. And now I can insert what I just copied from the secret. And then it loads the configuration from the object server. Here it is. And in here you can see user and groups management from the object server repository, which is usually almost blank because we manage our users within Dash or LDAP. Menus and tools, if you want to configure them, here they are. Automation. This is now the piece where we're going to dive in today. So mainly the triggers. In the triggers, these are the housekeeping triggers, which we're going to use. That there are like delete clears, generic clear, expire, deduplication. These are the 4 triggers we're going to talk about today. So let's make this a large window while it loads all the content from the object server. So this is the list of all the available triggers. You can see we have as default 171 triggers available in here. Not all of those are of interest for a normal administrator. Many are just there because they need to be there, for example, for this primary backup handshake mechanism, other integrations. What else do we have in here? So we have databases, of course, which is here. So in here, the databases are listed. The main database that is really interesting to all the integrations and enhancements that we are going to do is the alerts.status table. So this is the alerts database. In there are again many tables. And this one, the status table, that's the one which is of really interest to us. There's also the journal table and the details table, which has some interest. So for example, the details table is used for debugging purposes when we are working on probe rules files and we want to test out new rules and we want to push the raw data into the object server. This is the place where it lands. And the other one is the journal table. This one, the journal table is, for example, when you want to leave a trace. So somebody acknowledges an event, somebody does anything else on this specific event. This goes all into the journal table, and you can leave even normal text messages in here. For example, if you are in a shift pattern, have to hand over some context to somebody else, this is the place to make annotations to the events. So now, alerts.status table. So in here you can see we have 116 out-of-the-box fields. They start with acknowledge and they go all the way down up to X733 specific probe. That's the last field in here. And in between you can see different types. So varchar is the most frequently used. This goes quite significant up, 2K chars. There's increment fields, timestamp fields, for example, like UTC time. This is used for state change, first and last occurrence. There are integer fields when we just have numbers to represent in here. And really interesting for deduplication is the identifier field, because that is the key field for the whole table. And that's what's really interesting, and that's what makes the difference. If you have a new event that is coming to the system, then same identifier value means this is the same event and gets deduplicated upon reinsert. You can even amend this, which is cool. But you can easily add in here more fields if you want. You can change this table on the fly. I highly recommend not to delete any data in here because that may cause secondary issues in your environment, which you don't want. But if you want to add in here fields, here are buttons that you can use to add other databases, tables, as well as fields, and you can even change the fields with this edit column. Don't delete any stuff that is out of the box there. That is asking for trouble. Don't do that. Okay, now we know what the databases and the tables look like. Now we go back to our deduplication trigger that Zane has showed. Let's have a look how that looks like. So these are now all the available triggers in here, and we're interested in deduplication. So deduplication is something we have here. This is an out-of-the-box trigger. This triggers upon reinsert quite easily. What does it do? So when we do see a new event coming in, then it gets compared with the existing events in the alerts.status table. If there is one already, then we will see a record that's notified with old and then the field name. So old.field name is how you reference the existing record, and new.value, label value, this is how you reference the new to be inserted data. And by just setting these old values with the new data is how you assign them. And you don't need to do a commit or anything like that. This is creating the SQL statement, and the SQL statement itself will get evaluated upon the trigger time. So in this case, upon the signal of reinsert. So whenever a new event comes in and gets reinserted, that means there's already an existing value for the same identifier value, then this triggers. Okay, let's have a look into the rules of the Simnet Probe. So let's change. So where are the rules files of the Simnet Probe stored? So we are in the OmniHome probes Linux path, and out of the box we have two probes installed. One is the Simnet Probe, which is our demo probe. This one creates the events that we're going to play with. And there is a second probe, which is called the syntax probe. That is very handy to actually check if you make rules files changes, and because they need to be syntactically correct to make the probe start. If you have a typo in your rules file and you created a wrong syntax, then the probe will not start. And to prevent this, there's a syntax checker. So let's get into the Simnet Probe. So the Simnet Probe, the first thing which is there, and this definition file is used to define what are we going to create. So there are four types of events that are available. One is link up, link down messages. The other one is machine up, down messages. Then there are disk space messages. You can create a percentage of disk space that is used in here, and a port error. And the last one is the probability. The higher the probability, the higher the value, the more events you get. As you can see in here, we have ones and fives in here. You don't want to go higher than that, because if you really go high, you will have a lot of events to play with. So that's the definition file. Four different types, and the interesting piece is this is a positive negative match, this is a positive negative match, and this is just an error message which is coming into, and this is just a counter that gets different. These four different types of events we can create and play with. Let's have a look at the properties file. So the property file looks almost the same for all the probes. So there is a general purpose part in here about authentication, heart beating, these kind of things. Interesting, for example, is if you want to do debugging, then you want to have a look into the message level and the message log. So message log depicts where is the log going to. And the message level determines how much of information are we going to send towards the log. Best practices is, as long as you're working on the probe, doing your rules files editing, it is fine to go into debug. But as soon as you leave editing and leave something behind, then do not leave that behind open, because it creates a lot of log data in here. And you don't want to endanger your systems by creating too much rubbish. Okay, what else is interesting in here? The most interesting piece is, of course, where are we going to connect to? And by default, everything connects to a object server that is always called ncoms. This is the out-of-the-box value. So if you want to connect to my OpenShift-based servers, then we need to use a setting in here so we can make it into the props file. So whenever we raise this probe, then it will use this value, or we can use a command line value. Now let's look at the rules file. So what do we have? Simnet.rules. So what do we see in here? We have here a more general section, which is about going up and down. We see a switch statement that is used for that, which is a probe stat, which is type 2 is a resolution event, type 1 is a problem event. So then we have another section, which is setting variables. So this is what you do on block usually. And you can see in here, manager is set by a fixed string. This is the class values. For example, if you want to do very efficient filters, you would probably filter on the class value for the Simnet Probe. This is 3300, and if you filter for class equals 3300, then you get all the Simnet events into just one single filter. Node, agent, alert group, default summary, default severity, and now the important piece for the deduplication, this is the identifier construct. So the value of the node field, agent, severity, and group do make the identifier. And remember, same identifier means same event. And if you reinsert a event with the same identifier, then it will override the existing one for specific fields. Remember the ObjectServer trigger we just saw. You will update a few fields. For example, the tally field gets incremented, and you will override the last occurrence with the current timestamp using the getDate function in the ObjectServer. That's how to do it. So now let's have a look. What is deduplication really bringing to the table? For that, I have brought up here the event list. And from the event list, I can see that I have in this view, which contains all events that I have in the ObjectServer, 89 rows. 89 rows. That's the total of all these events now. Now, if I'm switching to my configuration window, and if I execute a SQL statement that sums up all the various tally fields, which is the count, then I do get a number that represents the total number of events that have been deduplicated. And if I do the math now, so this is 62682 events divided by 89 rows. So I see for each event in the event list, I have 704 originating events. And that is the factor that noise reduction is bringing to the table with just the first stage of deduplication, reduction of 1 to 700. There are customers which have different rates, but this is just an example, and this shows how powerful noise reduction is and must be. And if you want to know how to counteract this, then let's go back to the I do have a trick. I just told you that the identifier field is responsible for the deduplication effect. And if we make sure that the identifier is now unique for each and every event that is coming, then this little trick does it. We introduce a variable, count, and with each event that is coming through the rules file, this is a persistent value, this gets incremented by 1. For each event that is coming, this number gets higher, and just adding this to my overall environment makes each and every identifier unique. So in my example, I wouldn't have any more 87 rows. I would have all the original thousands and thousands and thousands of lines in my event list. A few more things for best practices. So first, let's have a look on how to get rid of events we do not want. For that purpose, we have the discard function available in the probe rules file. So never ever put the discard without a condition into the rules file, because that would cause losing all your events. So how this works is the discard is more or less a flag that is going to be set. Remember, one event at a time is processed by the rules file. And if at the end of the rules file's processing, the discard flag is set to true, then the event will be discarded. And so therefore, there are several possibilities to set this flag as well as to unset this flag. So to set this flag, you usually would do something like a reg match on a variable, and then you put something in here. So this, for example, checks for the summary if there's the string something weird embedded in there. And if that evaluates to true, then the discard flag is set using this function. There's also the possibility to do a direct match, which is this function. So if match node, so this is the object server value. So that's the already assembled value that is going to be forwarded to the node field in the object server. If that contains the exact string test node, so this is an exact match, then the discard function would be activated in here. There's also the possibility to check if something is discarded. So for example, you can use this function. And this is useful if you want to enhance your logging capabilities. So for example, you want to create a record if you discard something, not to lose some kind of information, or you have a specific process that requires this kind of thing for auditing purposes or whatever, then this is something you may want to consider. Because these kind of functions and logic trees can become quite complicated, you may want to have the possibility to recover things as well. So you set conditions before that may evaluate to true or not using the discard function, and you may want to recover a discard flag, and that's exactly what we do with the recover. Oh, here's a typo in here. So this is not correct syntactically. And by the way, this is not active code. You can see in here the hash at the beginning. Hash means the total line is going to be ignored. Just make sure you don't fuss around with the brackets, because that is also a very common error in here. And a last thing about rules files processing is the details function. So we have already mentioned there is a table in the object server, alerts.details, and every single record of an event from alerts.status can have multiple records in the details table. They are linked. And to create these kind of links, we use the details function. So the details function can be used to forward all the tokens that are available, which is this $, or we can put in here a specific token we want to forward. So for example, if we say we want to just forward the value of the node field to the details table, then we would put in here the node variable. Just make sure if you're done with your rules files processing, don't leave the details function on, because that causes a lot of extra data to be forwarded to the object server. And as long as these single events are there, which have the attached details records, then this burdens the object server, obviously, and you do want to household with your resources, so therefore do not leave the details function on. This is best practices. It's very nice for debugging purposes, but do not leave it on. That's all, and now back.
Okay, thanks Fred for that interesting demo. Now we move on to the next of the automations. This is the delete clears. So the delete clears automation is really a housekeeping automation, and it does as the name suggests. It basically, when events are cleared, in other words, the severity is changed to 0 and the event appears to be green, then the delete clears is the trigger that cleans up these events, deletes them basically from the object server. The logic behind it is that if the events have been there in the object server for at least 2 minutes, there's been no updates to it, and it's now clear, then the delete clears trigger will come through and clean up all those old clear events. Again, this is the trigger, as you can see in the Netcool administrator tool, and it is a temporal trigger which runs once a minute, and it's a very simple one. The details are simply to delete from the alerts.status table, which is the event table, where the severity is 0 and the state change is older than 2 minutes ago, 120 seconds. The state change field is updated, by the way, every time there's any sort of a update to an event. So if the event has not been touched, it's clear, then this trigger will come through and clean it away. Okay, so now Fred, over to you for a quick demo of how this looks in practice.
Okay, delete clears. So what we see here is these 20 lines are corresponding to already cleared events. So clear means problem resolved, and this is just a record in the object server just in case a reoccurring problem comes up. Then we still have the record for, by default, 120 seconds in the object server. After that period of time, all the clears are deleted, and that is to household with the resources of the object server. Keep in mind, it's a main memory resident database. And we do have to get rid of all the resolved issues. Now you can see, now this has changed from 20 to 4. This is exactly the effect that delete clears is delivering. It deletes all the untouched clear events after 2 minutes. That's it. And with that, back to Zane.
Okay, the next automation that we're going to look at is generic clear. So the generic clear automation is one of the main automations that are used to correlate problem events with resolution events. So let's say a switch has gone down or a link has gone down. The event will get an alarm come in, and then maybe 5 minutes later, the link comes back up again. We may receive a resolution alarm, a clearing alarm. That event will come in, and the generic clear essentially correlates the problem event with the resolution event, clears them both, and then those two events are eventually cleaned up by the delete clears trigger, which we just looked at. So again, this is performed by an object server trigger, just as before, and there it is there. If we take a look at it, it runs every 5 seconds, so it's a temporal trigger. And what it's doing here, this looks pretty complicated, but it's actually doing quite a simple thing. What it does in the first for each row loop here is it simply rounds up all of the problem events that are not clear, where the node, alert key, alert group, and manager happen to be the same as a non-cleared resolution event with the same node, alert key, alert group, and alert manager. And what it does is it inserts these, for each problem it finds, it inserts a note into this custom table called alerts.problemEvents. Just so it basically goes around and makes a note of all the problem events that we have currently that are going to correlate with a resolution event. The reason it does this is because a resolution event can potentially clear more than one problem event, as long as it's greater than 0 severity and the node, alert key, alert group, and manager match. So now we've made a note of all these potential problem events that could correlate. The second for each row loop then says, okay, for all the resolution events that I currently have where the severity is not clear, I want you to go through the problem events table that I just constructed and mark all of the events that are true where the last occurrence of the resolution event is happened after the last occurrence value of the problem event, and mark all of those events as resolved. And then the final step is to say, okay, for each one that I marked as being resolved, go back to the main alerts.status table and just clear those problem events. So this is how you can have a resolution event that may just clear down one problem event, or it may clear down several problem events if they happen to correlate. And then finally, we delete all of the problem events from the temporary table that we built up in the first step. The other thing that it's doing before it does that is it goes through and marks all of the resolution events to clear as well. So each time this trigger runs, it basically picks up all the currently non-cleared resolution events and tries to match them off against any current non-cleared problem events. By the end of the automation, all of those resolution events will be cleared, regardless of if they matched anything or not, and any corresponding correlated problem events that did match will also be cleared. And then the good old delete clears automation will come along and delete them all these cleared events after 2 minutes, after they have been sitting there for 2 minutes. Over to you, Fred, to show us the generic clear automation in action.
Okay, generic clear. So the effect of generic clear is that we create these cleared events. So currently we have 2,812 lines of cleared events. If I click on that, you can see loads and loads of these events that have been cleared. Why have they been cleared? Whoops, all gone. One is they can have an expire time. That is something we're going to see in the next piece of this presentation, because they do not correlate. All other events which should correlate do have the classification of being a problem, or if something was not done correctly on an administrator level, we have type not set. So these are the events we need to catch as an administrator. So everything should have a problem, resolution, or information setting, or at least an expire time. One of these settings need to be there. Type not set for the type field, can be problem or resolution or information. Nothing is not good. Also expire time. This is also not best practices. So seeing here a value which indicates something has not been set, that is work for the administrators. So let's dive a little bit into how do we get these values. You may have guessed it already, rules files from the probes. Exactly. So let's switch to our most beloved Simnet Probe. So the Simnet Probe itself has these values already set. We can see we have rules. If reg match means we're testing for something within these events, if we do have in the summary field the string, something can be before, something can be after, that's dot star, that's this what it means. So this is a regular expression, and in between we're looking for down. This specific string needs to be in this string value, and if that's the case, then the whole thing evaluates to true, and then these things are set. So it means identifier has a more specific setting. Severity goes to 5, which means this is a critical event. Type is set to 1, and 1 means this is a problem event. High severity, this goes high in the urgency, as well as the marker as this is a problem event, means we are going to categorize this event as a problem of high severity. This may be justified or not. So usually if something goes down, this may be bad in several layers, but it's usually not good. Therefore, having this as a problem denotified is a good idea and definitely best practice. If this needs to be severity 5, most critical, most urgent, this is something that you need to discuss in your specific environment. There are several layers of severity, starting of 0, clear, and then going to the various layers up to 5, critical. In between, you will definitely find something that matches your needs. And subsequently, down here, we have a secondary rule, and that matches all the events that have in the summary field the portion up containing. So this field in here. And remember the settings of our Simnet probe. There's a type of event that can be generated. That's link up, link down. These are these two messages, and they both form a pair which can be correlated. So type 1 is the problem, Type 2 is the resolution. And then we just need to make sure that the problem that is going to be cleared comes before the resolution. So there is a time constraint as well. But this is matched on the automation layer. The rules file just has to make sure that these events are classified correctly and the key fields of general clear are populated with the corresponding values. And the key field is definitely the type field, identifier field. There's also alert key and alert group in there, but these are already populated here using these field values. So we don't need to care about these in this specific sample. You may want to populate these, for example, if you want to go more specific. So for example, you have a router, the whole router can go down, a specific interface can go down from the router, and you don't want to correlate the whole router going down with a single interface going down. So for example, if the whole router is there, it has something like 48 interfaces, just one of the interfaces goes down, and there may be 2 or 3 more which are down. And if you're having then an up event from one particular interface, you want to make sure that the correct link match is performed. And that's how you would put these values, something like a link ID or any kind of value that you do have coming from the router is populated in the correct field. So alert group would be definitely something you want to populate, as well as alert key. So alert group and alert key are the fields to look at when you have these higher levels of details, when you do grouping and then details. Okay, and with that, we can go back. Back to you, Zane.
Thanks, Fred, for that demo of the generic clear automation. The final one we're going to look at is the Expire automation. So what is Expire? So this is another housekeeping automation, and this one's job is to basically ensure that no event stays in the object server indefinitely. This is important because we don't really want to be keeping old stale event or information data in the object server indefinitely, and it sort of revolves around the principle, best practice principle, that we should be sort of setting a time to live on every event that comes into our system. Indeed, there are housekeeping triggers that are provided with Event Manager in the Omnibus extensions directory, and they are documented on Knowledge Center, and we'll also be covering those in another SWAT Explained session in a bit more detail. But suffice to say, they revolve, the event expiry automation revolves around the setting of the expire time field in the events. So by setting the expire time field is basically setting an integer value in this field, and that integer value represents the time to live for that event. When the events come into the system, they've got their time to live. The expire trigger will periodically run, as we'll see, and what it does is it says, have any events reach their expiry time? And it calculates this by taking the first occurrence of each event, adding on the contents of the expire time, which is a number of seconds, and then saying, okay, is the current time, the get date, the current timestamp, is that now after what I've calculated? If it is, it means that the event's expired, and then I should clear it. We clear the event, and then the delete clears. So we clear the events, and then the delete clears automation, like we saw before, comes along and cleans those up. So let's take a look at the trigger itself. This is, as before, this is how it looks in the Netcool administrator. And just like the delete clears trigger, it runs once a minute as a temporal trigger. And it's a very simple one. It's saying where the expire time is greater than 0, where the severity is greater than 0, and where the last occurrence is before the current timestamp, get date, minus the expire time, then the event can be marked for clearing, because it means that it has expired and it can be cleaned up and removed from the object server. Right, so at this point, I'll hand over to Fred to show us an example of this trigger in action.
So in this example, we have now 16 rows of events, which are of type information, so they do not correlate using the generic clear automation, and they have an expire time set to 5 minutes. So that means 5 minutes added to the last occurrence means 650, and within that time frame we would expect those events to be cleared. So they would change the state from information to clear. Let's see. Now we can see a portion of those have been cleared. So we have new ones here and above, 14 new ones, and our 16 events have been cleared. So this is exactly what Expire does.
Okay, thanks Fred for that demo. That's very informative. Okay, well, thanks, Fred. Just a final note from me. This is where you can find best practices information around Netcool. Netcool being some of the core componentry in the event manager. It's basically the best practices site is ibm.biz/NCO_BPS, or that stands for best practices. Thanks, Fred.
Thank you, Zane. Yeah, this is the place where all the best practices are hidden, stored. And with that, I like to thank you as well as you, the appreciated audience. I hope you had some fun in this session and liked it. And as always, please drop us a notice if you want to see something else in another video. And I'm looking forward to the recording of part 2 and probably part 3. Let's see. Okay, so far, take care and see you next time.